Today we're going to learn about how to use parallel and perpendicular lines in equations and how to identify them in equations. So we're going to start with parallel lines, and just as a reminder, parallel lines never intersect. They're like railroad tracks. They run the exact same rise over run for both lines, so they never run into each other. So the way that happens, if they have the exact same rise over run, they have the exact same slope. They just started at a different y-intercept. So the way we check to see if lines are parallel is we're looking at the slope. If the slope of our lines is exactly the same, they're parallel. So example 1, very simple to see. We've got a slope of 2 on both of ours. And so it's very simple to see that, yes, these are parallel. Now I want you to pause your video and I want you to check number 2. Number 2, before you pause, number 2, one of the equations, the second equation, is not in slope-intercept form, and so you're going to have to solve it into slope-intercept form or solve it for y to check and see that the lines are parallel or not. So pause your video and decide if the two lines are parallel. Okay, so when I solved the second equation, I came out with a slope of positive 1/2. So since both of my slopes are positive 1/2, they are parallel lines. Now, perpendicular lines, you learned in earlier years, they are two lines that form a right angle. So the way that we figure out if lines are perpendicular is if their slopes are what we call the opposite reciprocal. In other words, when you multiply the two slopes together, they equal the number -1, or you could just say they are opposite signs and flipped upside down. So you can either multiply the two slopes together, or you can look and see if they're opposite signs, one's positive and one's negative, and they're fractions that are flipped upside down. So on the very first example, number 3, we need to have an opposite sign of a positive 1/2. So if it's positive, we know it's going to have to be negative. And if we flipped this 1/2 upside down, it would be 2 over 1. So negative 2 over 1. So we've got opposite signs flipped upside down. If you multiply those together, if you multiply 1/2 times -2 over 1, you're going to get -1. So we've made that a reciprocal slope. Now on number 4, we've been given -4. It's hard to flip a whole number upside down. But if you take a moment and remember that that's really just the same as -4 over 1, now it's easy to flip it upside down. So our opposite sign of a negative is going to be a positive. And then we're going to flip it upside down. So instead of -4 over 1, it's going to be +1 over 4. And if we multiplied those together, if we just said -4 times 1/4, it would equal -1. So either way that you see it, if you're given two slopes, you can multiply them together, or you can look and see if they're opposite signs and flipped upside down. So in order to determine if two equations are parallel, perpendicular, or neither, you have to look at the slope for each equation. Now, some of these equations on 5 through 8 are already in slope-intercept form. Very simple to find the slope. One of them is in point-slope form. Again, very simple to find the slope. But others need to be solved for slope-intercept form, or you need to use the points to find the slope. So what I want you to do is go ahead, and we're just going to do number 5 first. So go ahead and find the slope of both lines and make it a determination if it's parallel, perpendicular, or neither, and then check back for the explanation. Okay, number 5 was pretty straightforward as long as you were able to solve correctly. All right, go ahead, and I want you to do the same on number 6. It's already both in slope-intercept form. You just need to determine what kind of lines they are. So pause your video, fill out the notes, and then turn it back on to check the explanation. The big thing on number 6 is to notice that they're not the same. One's positive and one's negative, so they're not parallel, but they're not perpendicular because one of them's not flipped upside down of the other one. Okay, so on number 7 and number 8, I want you to go ahead and do both of those before starting the video back up. And then once you've got your complete answers written down for both, then check back on the video for the final explanation. Okay, both number 7 and number 8 turn out to be perpendicular lines. Both of them, when you find the slope using the slope formula or just identifying the slope in the two other kind of formats, you find that when you multiply them together, they equal -1. Or if you look at them, they are opposite signs and flipped upside down.